Suppose that scores on an IQ test are normally distributed with a mean of 110 and a standard deviation of 25. We want to answer 6 questions. We want to know, first of all, what does the empirical rule tell you about this data? Second, what percentage of people scored lower than 100 on the IQ test? Then we want to find the probability a person would score higher than 150 on the IQ test. We want to find the proportion of people who scored between 75 and 130 on the IQ test. If we score better than 95% of people on the IQ test, then what is our score? And if 95% of people score better than you do, then what is your score? Okay, so first, let's start with the empirical rule. Now, we were playing around with an empirical graph in the last video, but let's just use the rule without actually drawing a graph. We can if we want to. Actually, let's draw the graph. It might make the rest of these questions easier. So what does the empirical rule tell us? Well, we know that our mean is right here. It's 110. And a standard deviation of 25. So if we subtract 25 from 110, that's going to give us 85 over here. And then if we add 25 here, we're going to give 135. All right. And we know from the empirical rule that 68% of IQs, at least for this IQ test, should be in here between these two. All right, well, let's go further out. If we subtract 25 from this, we will go to 60. And if we add 25 over here, we'll go to 160. And we know that the empirical rule says that 95% of people who take this IQ test should fall in these bounds. And then finally, let's go one more standard deviation. If we subtract 25, we're going to get 35. And then if we add 25, we're going to get 185. And we know that what the empirical rule says is that 99.7% of people who take this particular IQ test should fall between those two values. All right, so that's what our empirical rule tells us about this data. All right, so what percentage of people scored lower than 100 on the IQ test? And let's notice in our picture that we don't have 100 labeled. So what we're going to do is we're going to use our z-score, and then we're going to look it up. And we'll talk about how to look it up. So let's use our z-score. Let's take the 100 minus the mean of 110 and put it over the standard deviation of 25. And that gives us negative 10 over 25. And I'm going to get this as a decimal. So negative 10 over 25 is going to give me negative 0.4. Now we're going to look this z-score up on a table. And this z-score always gives us the probability that we are lower than whatever this value is. So in this case, 110, that we're lower than 100. All right, so the probability that we're lower than 100 on the IQ test. So let's look up negative 0.4. So you're going to have some tables on the left-hand side in your menu, and one of them will be the cumulative normal probability. And so we're going to look up our z-score here on the left side. There'll be a negative z-scores, and there'll be another one that's strictly positive z-scores. Now we're going to look up negative 0.4, and right now it's running down the page, so let's pull the page up a little bit. And here's negative 0.4. Now, if there's a second decimal, we're going to search for it. So let's say it had been negative 0.45. We would look for the 5 up here, which is right here, and we'd have gone negative 4 and over to the 5 for the second decimal. But we just have negative 0.40. So that's this first value, 0.3446. So going back, this probability is 0.3446. So about, now, oh, I'm sorry, we're looking at this one here. So let me erase it and put it in the right place. Well, maybe. Point 3.446. Now it asked for the percentage, so let's change that into a percent by moving it 2 decimal places. That's approximately 34.46% of people would score lower than 100 on this particular IQ test. All right, now let's look at number 3. Find the probability a person would score higher than a 150 on the IQ test. So we're going to do the same thing we did for number 2, but we're going to use 150 instead of 100. And I want you to notice that this time it's higher. Now our chart only gives us the probability that we're lower. So we're going to do something extra for higher or greater than. So let's see, this gives me 40 over 25. 40 over 25 will give me 1.6. So we are going to look up a z-score of 1.6. All right, so I'm going to go back to that chart. And right now, all of these are negative. So I'm going to go further down the chart where we can see the positives. Here they are. And 1.6 is right here, 0.9452. Now, this is not my answer. Remember that I said that the table gives us the probability that we're less than 150 in our IQ score. To get the probability that we're greater than 150, we always subtract from 1. So for less than, we just look it up on the table. For greater than, we have to subtract from 1. And the area under a normal curve is always going to add up to 1. So we're just finding the area that's not less than 150, that's the opposite. So 0.0548 is the actual probability that we're looking for. Probabilities and proportions are interchangeable words. So let's realize this is exactly what we're looking for. If it was a percentage we were looking for, we would move the decimal and make it 5.48%. But both probabilities and proportions will be decimals. All right, now let's go back to number 4. Find the proportion of people who scored between 75 and 130 on the test. So since it's 2 different values there, we've got to do our z-score twice. And we will always have to for a problem that is between. So we're going to do 75 minus 110 over 25. And then we'll do, what was the other one, 130? 130. Minus 110 over 25. All right, so let's see. This is going to give me negative 35 over 25, which, if we put that into the calculator, is negative 1.4. And then I'll go ahead and finish this one. This is going to give me 20 on top over 25, which will be 0.8. Now, what we're going to do for any between problem, we look both of these up, and then we subtract the 2 probabilities. So it's kind of like being between this 85 and this 135. If we looked the 85 up on the table after changing it to a z-score, we would get this area or probability that's to the left. And if we looked up 135, we'd get this probability that's to the left. To get the probability that's in between, we have to subtract the bigger value minus the smaller value. So let's actually look these up, starting with the negative 1.4, and then I'll get the 0.8. So negative 1.4, going back to the table, I need to go back to the negative portion. Negative 1.4 is going to give us 0.0808. So, going back here, I'm just going to write it there for the second. 0.0808 is what this one gives us. And then let's look up the 0.8. 0.8, I'll go to the positive table. 0.8 is going to give us 0.7881. 0.7881. Now you notice I put the bigger one on top because I'm going to subtract them now to get the actual probability. So if I go 0.7881 minus 0.0808, that probability is actually 0.7073. There's our final answer to that problem. All right, now let's go to numbers 5 and 6. All right, so number 5, if you score better than 95% of people on the IQ test, then what is your score? All right, so let's draw us a little picture here for a second, and I might have to do another page because it's at the bottom of this one. So if you score better than 95% of the people on this test, you're over here somewhere. Here's the mean and 95% probability that all of these people are below you, and you're some score over here. So here's what we're going to do. We're going to go backwards on the table. We have to find the closest thing to 0.95 in the body of the table and find the corresponding z-value. So let's go to the table and try to find the closest thing to 0.95. So if we search the table for 0.95, we find right here 0.9495 and 0.9505. So our z-value is directly between these two. Now this, if we look over here, is 1.64, and the one next to it is 1.65. So we're going to call this z-value 1.645. It's directly in between those two. So 1.645. We are going to take our z-score backwards. So we know the z-score. We do not know x. We know our mean is 110, and we know our standard deviation is 25. And we're going to solve this equation. All right, so, well, let's multiply this both sides by 25 just to get it out of the denominator. 25 times 1.64 gives me 41.125. And then these 25s cancel, and I get x minus 110. And then let's just add the 110. And we get that the IQ that will be higher than 95% of people will be 151.125.